Okay, number 20 is a goodness of fit test. A teacher figures that the final grades in the chemistry department are distributed as A is 25%, B is 25%, C is 40% of the grades, D is 5% of the grades, and F is 5% of the grades. At the end of a randomly selected semester, the following numbers of grades were recorded. Determine if the grades distribution for the department is different than expected. The expected grades are what's listed in the problem. The 25% of them are A, 25% are B, 40% are C, 5% are D, and 5% are F. So here's how we list the null in the alternative hypothesis. You begin. HO always is the distribution is as expected. And you can list this distribution, or you can just say the distribution is as expected or as listed above. The null alternative hypothesis is distribution is not as expected. Okay, he wants us to determine if the grade distribution for the department is different than expected, so the claim is in H1. Okay, I'm going to show you how to do this problem using the calculator. In L1, you're going to put the observed values. Observed values, they will be the one that's given to you in the table. So these are the observed values. And the percentages are the expected values, and I will show you how to compute the expected values. So we're gonna go to the calculator. We're gonna put 42, then the next one is 36, then 60, then 8, then what? 14. Oh, let's fix this one. That's 36. Enter. 60. Enter. 8. And then 14. Okay, L2 are the expected values. How do we compute the expected values? You take the 25% for A, but you compute 25% of the total. So you must add 42 plus 36 plus 60 plus 8 plus 14. If you add them, you get 160. So 25% of 160 will be what? 40. B is 25%, so it's going to be 40. Again, it's a percentage of the total. C is 40%. Of 160, so 10% is 16, that would be 64, and that's gonna be 5% of 160 will be 8, and another 5% will be 8. Let's quit, and we go to stat, tests, and you can scroll up, and the test is chi-square goodness of fit test. Okay, as you can see, the calculator is asking me, are the observed values in L1? Yes. Expected value in L2? Yes. Degrees of freedom. The degrees of freedom for goodness of fit is the number of categories minus 1. I have A, B, C, D, E, 5 categories, not minus 1, so it should be 4 here. Calculate. And here's your chi-squared. This is the test statistic, it's called chi-squared, 5.25, and the p-value, that's what we need. The p-value is 0.2626, which is more than alpha at 0.01. So what's your decision, guys? Fail to reject HO. the conclusion, there is not enough evidence at the 0.01 level of significance to conclude that the distribution is not as expected. We cannot reject HO. Distribution is not as expected. We're not saying that HO is true, but we're saying that we cannot reject it. So that's number 20. 21. A sports statistician is interested in determining if there is a relationship between the number of home team and visiting team losses and different sports. A random sample of 526 games is selected and the results are given below. Test the claim that the number of home team and visiting team losses is independent of the sport. Use alpha equals 0.01. This is called an independence test. So, and this is what section 12.2 is about. And this is how you state HO and HA. HO is always the variables are independent, and H1 the variables are not independent, means are dependent. So what are the variables here? That the number of home team, number of home teams, home team and visiting team losses is independent of the game, or is independent, yes, independent of the game. Or independent, yeah, of the game. So that's what the claim is. HA is, or H1. Again, guys, whether you write HA or H1, that would be okay. Some books use HA, some books use H1 for the alternative hypothesis. Number of home team and visiting team losses and the sport are dependent. So again, HO variables are independent, H1 variables are dependent. And is asking me test the claim that the number of home team and visiting team losses is independent of the sport. Use alpha equals 0.01. Okay, let's run the test. I'm going to show you how to use a calculator to run this test. So you're going to go to first of all, you're going to enter the observed values. What's given to you are called the observed values. So we're going to enter them into what we call a matrix. And let me show you how to use the matrix. So we're going to go to second, matrix. It's under X inverse. Okay, A, we're going to go to edit. Okay. This matrix has how many rows and how many columns? It's the data, the actual data values. So you have 2 rows of data and 4 columns of data. So it's going to be a 2 by 4. And look, 2 by 4 was created for you. You're going to fill it in now with numbers. 39, 156, 25, 83. And next one, 31, 98, 19, 75. Okay, now we're gonna quit. We're gonna go to stat, tests, scroll up. This is a chi-square test. It's called chi-square test. So again, these are the observed values right here. And now we're gonna do the chi-square test. Okay, let's go to the test. Okay, it says observed in A, expected it will put it automatically in B. Let's go to calculate, and here we go. Chi-square is, let me just read it again, 3.888. And the p-value is what? Looks like it's a big p-value anyway. 0.27381. Well, all we care about this is more than alpha. 0.01. So what's the decision, guys? You notice most of the problems we fail to reject HO. I didn't intend to do that, but it just happened like that. So what's the conclusion? Fail to reject HO, and the claim is in HO, so there is not enough evidence at the 0.01 level of significance to reject the claim that number of losses, that the number of home team and visiting team losses is independent